Hey guys, this is Joeteck, KD2GAG for ID 73s. I have purchased a D-HAP from Power Hardened Systems. They make the device is called a D-HAP, but it's called Digital Ham Access Point, and it's a great unit. I've run into some technical issues with it in terms of, not with the device. The device is fine. It's more or less my issue. So what I've decided to do, there had to be a way, and I had to figure out a way how to. I wanted to create a power down button, a shutdown button that will gracefully shut down the Raspberry Pi. There is a programming language that is built into the Raspberry Pi, or Linux I should say. It's called Python. I watched a lot of YouTube videos to understand how to program the GPIO pins on the Raspberry Pi. It's relatively simple. I mean, you're gonna laugh once we get started, and I show you how this is done. We're going to start from pretty much the starting of programming the pin and the pins that we need, and we're going to go all the way to the actual installation of the buttons and a working product type of thing. So we're going to go from start to finish with this video. So without wasting any more time, let's get right to it. So what we want to do, the power on the D-HAP, which is powered on, I have it turned on, and that's why you see these two programs. PuTTY is an SSH access, so we want to log into the Pi. By default, it's Pi is a username and Raspberry is the password. And you log in to the device, and then we want to run the VNC software, which is X11 VNC. And once that's done, on the right hand side, this is obviously a Windows machine. You want to download this program, Tight VNC Viewer. It's great, better than VNC itself. You connect to it. Password for this is also Raspberry. Oh, gotta type it right though. And we're in the Raspberry Pi. Now, this is the more technical side of it. I'm gonna make it as easy as possible for you guys because it was very difficult for me to finally figure it out. It took me 3 or 4 days to finally get all the data together. So this is going to be a rip-roar, easy. I'm going to put the code in the description so you can just cut and paste, and off you go. So it'll be much easier for you guys to do instead of researching it yourself and try to find the code and try to copy it down from the video. It's a pain in the neck. So I'm trying to make it as easy as possible for you. So what we want to do is, what's really cool about the Raspberry Pi has got pinouts. Let me move this picture over so you can see what I'm talking about. These are the pinouts for the Raspberry Pi. So we have pin 1, 2, 3, 4, all the way down to 26. We're looking at the center image here. This is their first revision, second revision, and this is their Raspberry Plus, which obviously is a larger unit. So anyway, this is the one we want to look at. So what I've done is that I'm controlling what is it, pin 25 or GPIO.25 and ground. So what we're doing is we're going to be controlling pin 20 and 22. I'll get you another graphic so it'll be easier to see. So essentially those are the two pins that we're going to be using for the shutdown of the Raspberry Pi. So we're going to write a piece of software in Python to control the GPIO.25 pin, which is so cool. All right, so let me close out of this picture. Let's close out of this picture, and let's go into accessories. We want to hit the little icon on the bottom, which it's like almost the start button for XP or Windows 7, whichever. And this machine happens to be Windows 7, but it doesn't really matter because we're in the Raspberry Pi, and we want to go into File Manager. Now, to make stuff easier, by the way, it's a little slow because it's not a rocket ship. It's, you know, It's a single core 700 megahertz by default CPU, and there is a piece of software on here that allows us to overclock the processor if you want, up to a gigahertz. That's at your own discretion, of course. I have mine at 800 megahertz because it offers a little bit more oomph to the system, since I am running this script that constantly monitors pin 25 status. So by default, you probably do not have a scripts folder. So what you want to do is right-click an open area, create new folder, and create a folder called scripts. As you can see, I already created one. So I'll wait until you can follow along and do this together, that's fine. And then you create a scripts folder. Inside this, we want to create a blank file. So we right click here, create new blank file, and name it shutdown.py. Then we want to right click it. Once you do that, you want to right click it and then go to LeafPad. And it'll open up the it'll be a blank file. But for this purpose, this is the actual code that we're going to be using for that particular file. This code will be in the description, so you can just cut and paste. So now, how do we get it to run? How do we get this to function full time? So now we have to go and do that. So hang on, let me close this application. Okay, now that we close the application, now we want to run the LX terminal, which is, you should have it here on your desktop. If you have a Raspberry Pi with your D-VAP system, you should have the LX terminal. If not, I'm sure you could probably find it in here somewhere. Let's see, accessories, LX terminal, there it is. I'm going to run this. Now we want to remember where this script is. So it's home, pi, scripts, and then the name of the file. All right, so now that we're here, we want to type in this command, because we got to work in a location called, or actually a file called rc.local. So sudo is like the administrator account. Sudo, or sudo, you say tomato, I say tomato. Nano space /etc /rc.local, and then hit enter. Now this will bring up this. Now this is a real-time editor. You could move your cursor around anywhere you want, the up and down arrows, and you want to put in this command, which I remember asking you to remember the location of that file, which we can clearly see. We still have it open up here, so we know the exact location of the script. /home /pi /scripts, then the file name shutdown.py. So at first, this file may not exist. So you're entering the line where it should be, and you type it in sudo python, which is the name of the it's actually, hold on, let me just show you something real quick. Go to programming. idle 3 is actually the Python program. If you want to do some testing and stuff like that, if you want to run the like each the code that we entered in, if you want to do it manually each time just to see if it works, you can actually run this, which is cool. And you could simply just cut and paste the entire script in here and run it, and then press the button on your Raspberry Pi in your possible research and development environment to see if it actually functions. Then you can do that. Eventually it'll come up. It's taken forever. There we go. Finally, there it is. Like I told you, the machine is not that fast. So this is Python. This is the shell where you actually type in all the code and stuff, if you wanted to do it that way, which you can. But we're not going to do that because everything is technically done. So anyway, as you see, you simply type in your information here, sudo. That's the only thing you modify. You do not change anything else. You just put in this line. That's all you do. And then you go up to File, and where is it? I think it automatically saves if you make a change. I think that the word save comes up if I make a change to it. And then you save it. And then the software part of it is complete. That is it. That's all you have to do. And then the hardware side of it is what comes next. So what we're going to do here is that I want to show you how this works. If I press the shutdown, now this is the programs that run for the D-VAP communications with the Raspberry Pi. As you can see, I'm linked because I'm connected to network, so it's actually linked to Reflector 20 Alpha, and the D-VAP node. This is the software for the actual D-VAP hardware itself. So so what I'm going to do is I'm actually going to press the shutdown button. Watch what happens. It's actually kind of cool. I want to shut down the I'm not sure if you heard the audio, but it dinged once. There we go. So connection has gracefully closed. Server unexpectedly closed network connection because I was connected to the VNC. So the Raspberry Pi is now shut off. So we power off the Raspberry Pi, and that is it. Let's move on to the hardware installation of those two switches. Actually, before we get into the mechanical portion of it, adding those two switches, the reset and the shutdown, I want to show you how to overclock the Raspberry Pi. So we're going to log back into it, just because we need to. And at this point, we're not going to VNC into it because we want to actually run another cool little program. It's the config file of it. So we config program is sudo space RASPi-config. Enter. And a little DOS window comes up. And in here, we're going to go right to overclock. And obviously gives a warning: beware that overclocking may reduce the lifetime of your Raspberry Pi. If overclocking at a certain level causes system instability, try a more modest overclock. Hold down Shift during boot to temporarily disable the overclock. See that website for more information. Hit OK, or Enter for that matter. And those are the options that you can do. I do modest. I don't do medium. 800 megahertz. I don't want to overvolt. Overvolt means adding a little bit more voltage to the CPU to increase the performance of the CPU. I think 800 megahertz is perfectly fine. And then everything. This is perfect. There's no need to go radical on this because it's just running your D-VAP and your gateway program. So I go to modest, hit Enter, and there we go. It's set, and that's how you do it. I'm not sure if you've expanded your file system on your Raspberry Pi, but that's also required, or you really don't have to do it, but it would be a good idea if you did. If you haven't done it, just hit that expand file system, and it pretty much goes. Alrighty, now we're off to setting up the physical hardware of those two switches. We'll see you in a little bit.
Hey guys, this is Joeteck from Joeteck PC Services. I have picked up a D-HAP, which stands for Digital Ham Access Point, and I'm not going to go into details of what this actually does. If you're watching this, then you know exactly what it does. This is for real quick, I guess I'll run down. It's a D-Star hotspot that communicates with your cell phone. It includes a D-VAP, which is a digital access point, and it also includes in this package a Raspberry Pi, a 12-volt source, and the company who makes this beautiful thing is Harden Power Systems, located in Tennessee. It's made in USA. This is their first model that they came out with, called the D-HAP MK1, and it works perfect. There's nothing wrong with this unit. It works absolutely fine. However, what a lot of ham guys have been doing, they program their Raspberry Pi to allow a program to be sent from the radio, but you have to program the Raspberry Pi to accept that input to shut down or reboot the Raspberry Pi, and I find that actually I don't like it. I have a 5100 and I can't get it to work. So what I've figured out to do is to use a mechanical switch. I programmed the Raspberry Pi to use a script written in Python, and the script continues to run and waits for a wait state. I programmed, there's a header here. This header here is a bunch of GPIO pins on it, and I programmed pin number 25 to wait for a low, and when it does, issue the sudo shutdown-r now command. So that's essentially what this does. So what we're going to do is we're going to physically add the mechanical switch, and a whole nother video will show you how to do the software modification for this as well. So anyway, pin number, it's the fourth one in from the top. 1, 2, 3, 4, and it's GPIO pin 25 to ground, and that's what it's sensing for a switch, and it works fine. I'm also going to add a reset switch, a soft reset switch. If we look closely here, we're going to zoom in here. There is a I have to grab a jumper pin. But if you look carefully at I guess the C12 and then P6 and then D18, there's an open area here for a jumper. That jumper is going to be for a soft reset, so we're going to have to pull one off of a motherboard that's dead, because I can't. Radio Shack for some reason does not sell them. Figures. I was just there, and we're going to throw a jumper there, and that'll be for the soft reset. So we'll be back. We're going to dismantle this and add that jumper. It's simple. If you know how to do soldering, and if you're in this system as is like this, then you know what to do in terms of soldering. But it's pretty much self-explanatory. Put the jumper in, flip it over, solder it in, and you're good to go. What we're going to do is we're going to add that reset switch and power off switch, and we're going to use this as the reset switch. It's very small. I'll show you in terms of a penny. We don't need anything radical. It's just we're going to drill a hole. I may have to cut this down a little bit because it is a little too tall, as you can see. We'll have to see what we could do. Maybe use a little hacksaw and chop that right off to make it a little shorter, or increase the height with a tube or something. I don't want the button to be accessible. I want it to be recessed in the chassis, so it's hard to get to on purpose. So you use a pen or paper clip to do the shutdown. We don't want to accidentally hit it. Same thing with the reset as well. So we're going to reset that as well, recess that as well. We also may even add, I haven't opened it up yet, we may even add LED lighting to it, so we know that the unit is powered on, and when the unit is off successfully, the LED light will go out. So these are green LEDs that I'm not sure if I'm going to add to it. We're going to see how it works out, and I'll let you know. We'll be back shortly. Okay, I've drilled 2 holes on the inside of the D-HAP. There they are. One will be for a soft reset, and the other one will be for shutdown. The button, I'll show you how it looks. It looks perfect. I don't have to cut it. So here's the button. I'm going to slide it in just so you can see what it looks like. I'm not going to connect anything yet, but this is what it looks like. If I get it to focus, it'd be perfect. As you can see, it's recessed just enough, which is perfect. You can't accidentally press that. That's awesome. That's what it'll look like on when it's finally finished. Okay, I just soldered in the jumper for that on the Raspberry Pi. I pulled it off of a motherboard that I'm not using. This is a motherboard that I'm not using. Pulled off one of the jumpers on the board. Actually over here, I think. Where did I pull it off of? I forget. I just did it. Remember what I did? Oh, there it is. right there. I pulled it off right there. Very simple. You just heat up both pins at the same time. Hold on to. I flipped it over and I just let the gravity take over. And I have a pair of pliers. I pulled that and slide it right out. That's where the jumper I took out of. And I soldered it. I have a piece of paper. I was having a piece of paper hold it in. So let me just. I actually had to take apart the Raspberry Pi, and there's the jumper right there. That's for the soft reset. So now we have to wire it up now and put it in those two little holes, and we should be good. Be back. I'm using this cable is from a DVD. It's like for digital output to the motherboard, or from the DVD player to the motherboard, or sound card. At the time for digital. Now it just passes through the SATA cable or IDE cable, and this used to be the connection. So I'm going to be using this on the jumpers. I'm going to disconnect one of the wires because I just need the two black and white wires because they happen to be together. And for strength and everything, it'd be great to leave it as a 4-pin connector because I'm not going to use it. I'm not going to use the other two, so I'm going to physically remove the other pin if I can. See if I can do that. I may be able to do that with it. Just poke that and it'll slide right out. Well, I'll just cut the wire and that'll be the end of it. And I only need the black and white wire. So when it's on the Raspberry Pi, I just need it for those two. I'm going to do this probably. I may cut this for because I have another one of these. I may cut it for the reset switch because it's a little too big. Actually, it really doesn't matter because it's in there. But you know what? And for cosmetic reasons, you know, I'm a perfectionist. It's got to look nice too. So that's what we're going to do. Okay, I made a modification to it. I didn't want to use the black wire, so I removed it and just used the pink and white of the connector, and then I soldered on to the switch. If I get it to focus, it'd be great. Holy moly, there we go. And then I soldered onto the switch very carefully. This is going to be hot glued into that spot. So this could be either the reset switch or the power down switch. Doesn't matter. I'm going to make this one the power down switch. So let's install it. Here's the D-HAP. And since we're leaving it, we're going to leave the 4-pin connector because it works perfect for better support on the connector. Plus it makes it easier to make sure you're not going to make a mistake. And that's there. And then we're just going to put this into one of the holes and hot glue it in, and we're good. So let me come right back to that. Okay, I just finished hot gluing the switches in place, and they go to the appropriate location. I had to bend the wires a little bit, the pins, to put this on an angle because it actually comes down and hits the wire management system of the D-HAP. So I just put a slight bend on it so it can fit, and it just barely passes that wire management. Since you're not going to be opening and closing this anymore, it doesn't matter. This is it, unless you want to program, which I may do. I may do one other thing. I bought an LED that I may want to see when the device is actually powered off. Because it's probably within 15 seconds of you hitting the power off switch and the system's off. You can, when this is closed, you can look through the slots of the D-HAP and look at the LEDs that are here. Obviously you have power here and activity, but activity, if the system is powered on, would blink every 2-3 seconds, so you know the system is operational. When you shut it down, it actually does 4 or 5 blinks right before it's fully shut down. So then it's obviously off. If you don't see any activity, it's obviously down. And that's pretty much it. And if you shut it down and you accidentally did it, which I highly doubt, but then you can hit the reset switch, which is a soft reset because the system is still turned on. The power switch here is still turned on, and you still see a readout here with voltage. Then you can simply hit the soft reset button, which is what this jumper does, and it'll reboot it and it'll restart it back up again. So let's put this back together and see how it works. Okay, now the device is booted up, and I plugged in the network cable so I could prove to you that the power button actually works. So I'm actually SSH'd into the Raspberry Pi. I'm going to log in. I'm going to run the VNC X11 VNC. So then you'll see more activity on the hard drive, which is on the far left. You're going to start seeing a heck of a lot more traffic on the device of the activity. Okay, now we're VNC'd into it. Alright. So what I'm going to do is I'm going to show you that this button works. So now I'm going to take a paper clip. I'm going to hit shutdown. And that's the button I just hit, the shutdown button. The link in activity in 100 should shut down. And there's the blinks. Now it's off. Now you can power down the unit by hitting the power switch here. Or you can hit the soft reset. We'll hit that button now, and we'll reset the device. And watch what happens. The link power comes back on. The device boots up again. I find having a hard reset and power down mechanical versus allowing my radio to do it, just in case you forget. What happens if you forgot to do it? This will prevent your Raspberry Pi in your D-HAP to get corrupted. Because this is a pain in the neck. You don't want to have to worry about redoing your whole configuration and everything. It's a pain in the neck. So we're operational again. Now the system's booted up. Let me SSH back into it using putty, and it's coming back up. As you can see, log in as. So now we're back up and running again, and that's that. So if you like this video, please subscribe and comment below, and hope you enjoyed it. Take care. Hey guys, this is a little add-on I did. I needed I wanted to know when my Pi actually turned off and turned on in physical with a power light. So what I did was I used pin 8 and pin 14. Pin 14 is ground and pin 8 is GPIO 14. You don't have to do anything. It works by default. So when you power on the device, the LED comes on, and when you shut down the device, the LED goes off. So it works perfect. There's nothing to do. So all I did was I had this straight through jumper, and I literally just put the LED right into the pins right here, and I actually angled it so I angle the LED. Nothing's permanent here. It's just because I'm not going to open this up anymore. And I finagle it in the bottom of the into the D-HAP so it's facing down, and it actually shines bright enough to penetrate the white plastic. So pin 8 and pin 14, they're both on the same side, as you can see, and that's pretty much it. Alright, here is the Raspberry Pi powering on. I have the LED facing down onto the bottom of the case, so you can clearly see the LED when the system is powering up. or even on. It stays on for the entire time. This is how you know the Raspberry Pi is actually functioning and powered on in the power on state. So you obviously it's running. So we'll shut this down. There we go. Our system is off. We can hit the power switch and shut it down. That's it. If you like what you see, please subscribe and comment on below. Thank you.